Okay, so on this question, they want us to use L'Hopital's rule. And let's be clear, what is L'Hopital's rule? That says whenever we have 0 over 0 or infinity over infinity, then take the derivative of the top and the bottom separately. And separately is kind of the key word there. Okay, so let's get back. Let's plug in a 0 because x is going to 0, right? Plug in a 0. So what do we get? 1 minus cosine of 0 over 1 minus cosine of 0. Well, cosine of 0 is 1. So we get 0 over 0. You might think, okay, good, that's 1 or 0 or something. No, no, no. That's indeterminate. We cannot determine what that is. We have no idea what that is. That's we can't determine. It's indeterminate. You mean that again? You might say, well, 0 on the top is 0. Well, 0 on the bottom is infinity, and maybe the whole thing's 1. It's just unclear. We need to look at something else. And in fact, when we get 0 over 0 or infinity over infinity, we're told that we can do L'Hopital's rule, which means we can take derivative top and bottom separately. So that's what we're gonna do. So now in the next line, I'm going to use L'Hopital's rule. I'm going to use his rule, which is what? Normally they go equals, they put an H over it. That's how they indicate it, but it's just tradition. You don't have to. So limit as x goes to 0. Okay, I'm going to do the derivative of the top and the bottom separately. So what's the derivative of just the top? The 1 just goes to 0. Minus, what's the derivative of the cosine? Negative sine. Got double negative. The negative from the formula and the negative from the cofunction. All cofunction derivatives are negative. Keep the inside unchanged at first, times the derivative of the inside, which is 3. On the bottom, same thing. Get rid of that, minus, and then minus again, sine. Keep the inside unchanged at first, times the derivative of the inside. Okay, great. So what? What does that do for us? Well, um, we can plug in x going to 0, so we can plug in the 0 again. So what are we going to get? Well, the sign, you're going to get positive. Double negative is positive. Sine 0 times 3, positive sine 0 times 7. What's the sign of 0? Well, the calculator will tell you, Desmos, it's 0. So it's 0 times 3 over 0 times 7. It's 0 over 0. That's unclear again. It's like what we got before. We're getting nowhere. No, actually, we are getting somewhere. We just have to do Lopi again one more time, and that'll do the trick. So L'Hopital's again one more time. Here we go. Lopi to the rescue. So the limit as x goes to 0. So now this double negative is positive, as you know. Okay, so I'm gonna do what's the derivative of sine? Derivative of sine is cosine. Times the derivative of the inside. And then that 3 that was already there, yeah, I'm just going to put this 3 in the front, right? Just put it in the front. So, but the derivative of sine 3x is cosine, and then chain rule, another 3, right? And then on the bottom, same thing. I'm going to put the 7 in the front. So put the 7 in the front. And then what's the derivative of sine? It is cosine. Keep the inside the same times the derivative of the inside. All right, so there we go. Now let's plug in that 0. Plug, right? Because x is still going to 0. Plug in that 0. What do you get? Well, now we've got on the top 3 times, here, want me to keep the colors the same? Is that helpful? I'll do that. So 3 times the cosine is 0 times 3 on the bottom. We've got 7 times the cosine of 0 times 7. And what is the cosine of 0? It's 1. We got 3, we got 7 times 1, 1 times 3. Oh, well, I guess it's, I don't know why I changed colors again. Times 3 times 7. So when all is said and done, 3 times 3 is 9, 7 times 7, 49. There we go. Lopes did the trick. We had to do Lopes twice. And so there we go.